Warm and sunny welcome to this session. So my name is Sheen Brisals, and I work for the Lego Group. I am kind of active in the serverless and AWS community, so I have the privilege to be known as AWS serverless hero as well. And I often write blog posts about serverless experience, and you can also follow me on Twitter as well. Right, so today's agenda, so I will give a glimpse of what we are doing with serverless at the Lego Group, and then we'll focus on a couple of slides on just to set the tone, what is and why we need serverless, and then we start looking at patterns and some of the serverless patterns that we use as part of the work that we are doing at the Lego Group, and close with what are the benefits and few resources. In between, I will also kind of touch upon how the sustainability becomes important and part of the whole serverless technology as well. Okay, so what are we doing at the Lego Group with serverless? Now, this is lego.com. Now, we moved to serverless back in 2019. And often people ask, okay, that's fine, but what exactly are you doing with serverless at lego.com? And if you visit lego.com, say you purchase something, you pick an item, drop into the basket, you move on to make your payment, and then you complete the order, all sorts of validation and everything. Behind the scenes, all the microservices that support those activities for the front end are 100% serverless. So that's sort of the the serverless around lego.com that we are doing. So this was migrated from the old legacy platform back in 2018 and 2019 when we completed. But now the back end of lego.com runs fully serverless. The front end, which is the typical React, JavaScript, Node.js, and also we have the middle layer or the back end for front end GraphQL layer. So they run on Fargate. But if you look at all the services behind the scenes, they are all serverless. So that's where kind of the serverless movement started at the Lego Group. So when I say Lego Group, I should make it clear that this work becomes part of a bigger department or team called Marketing Channels Technology, which comes under Digital Technology Organization. Whereas if you look at the different teams across the Lego Group, there are a bunch of different technologies. We still do the on-prem stuff. We have big SAP establishment systems in place, and teams are also working on containers and Kubernetes and clusters, and also the typical monolith systems also there. Typical enterprise you can think of, everything in place. Okay, so when we started, this was the first service that we put out to production when we moved towards serverless. So based on the experience and the success that we saw, we kind of gradually kind of expanded across to all the different the services behind lego.com. So going back to a few years, so that time we had no serverless and few engineers, and then by the time we deployed, we moved to serverless, we had like 20 engineers, but typically the typical back-end, front-end kind of team setup. So if I fast forward to now-ish, so there are more than 20 product squads now. So product squads, I mean, the typically 8 to 10 people forming a squad, and they own a particular product. For example, if I say checkout, there's a squad, they look after the checkout services as well as the front end, similar to payments, loyalty, et cetera. And then number of services, I lost count because we operate now with different cloud accounts. So like I mentioned, the different squads, nowadays they own their own account, and they operate with their own repositories and stuff like that. So basically over 100 microservices and plenty of Lambda functions and things. Okay, and these sort of the spikes and graphs these days are very common. Even a few days ago, May product launch, we had similar spikes. And when it comes to serverless, we kind of don't need to do anything. Sometimes, depending on the occasion, we may provision concurrency set on few Lambda functions that are will be hit hard, but otherwise just nothing. It just scales up, comes down, as you would expect. Okay, so what is serverless? How many of you are kind of familiar or working with serverless? Okay, quite a lot, thanks. So before I get to serverless, let's quickly go through the evolution. I'm not going to go all the way back. You must have heard from the, the keynote earlier, the evolution of Microsoft technology and things around. So it's all kind of started with hosted data centers, and we had infrastructure as a service, then came the platform as a service, and from there, basically, the whole evolution of the function as a service, the FaaS, and that kind of, brought the serverless to the forefront. So that's where, the serverless kind of came into and became popular with, different cloud providers. So what is it? It's a cloud computing model, no manager. You don't need to kind of manage our containers or clusters or anything. And you pay for the compute. And also, if you're storing any data, you may, pay for that. And auto scale, highly available, everything is fine. So the thing is, I'm interested in talking about why we need serverless, because often people think that when we say serverless, oh, it's just the function as a service. No, it's not. Function as a service plays a part, whereas serverless ecosystem itself has a number of managed services. They come together to provide us the, the solution. So, and the optimization graph, this is another thing I like, because if you work with serverless, you know that you can tune resources individually. If you have two functions in a service, in a microservice, you can tune them separately. You can give them different security credential or access rights. So that is the power of serverless, in my opinion. That goes all the way. So deeper level security, data privacy. If you have two data tables, you can kind of set them up completely different. You don't need to kind of generalize. So that's sort of the flexibility. And the two other important aspects I like is, it's an ideal technology for iterative development. So you don't need to kind of build everything upfront and bring it up. Just start with your POC or the MVP or the minimum viable stuff, and then kind of iterate and get over. So this is the the kind of the more common the approach people or the teams follow these days. So it's ideal for that. And the other thing is the engineering diversity. What I mean here is that if you come from the traditional setup, you say that, okay, I'm a C++ or a Java programmer or JavaScript, things like that. Whereas when it comes to serverless, you are more than a programmer. You need to know about security. You need to know about event-driven computing. You need to know about messaging. All these aspects come together, and that makes you as a complete serverless engineer. You're not just a programmer. So that's another beauty of the technology. I always stress this point out. So okay, so those are the things to do with serverless. I'm not going to go into details. So let's go on to patterns. So while I was preparing for this talk, I gave this talk a few years ago. This phrase came to me. This is absolutely true when we think of patterns. So you see patterns on top of patterns, you patterns within patterns, you patterns hidden by patterns, all sorts of things. So there is no kind of a clear-cut definitions to say that, oh, this is what the pattern is and this is not, okay? Because if you think that way, we wouldn't have any of the other books other than this one, right? Gang of Fours pattern book. Why we have all the other books? Because there are different patterns, like J2E. If you've been through that, Java ecosystem, you know that the EJBs and those kind of things. And the Microservices Pattern, Chris Richard's book. So that talks about patterns related to microservices, like event sourcing and things like that. So the Gang of Four original book was kind of influenced by those days, the C++ or the object-oriented programming. It was true, it was good. But then things moved on. We have enterprise integration patterns. So it talks about, say, dead letter queue, DLQ, as a pattern. But nowadays, if you work in cloud and serverless, you would think that, oh, is that really a pattern? Because that's kind of common day use in your, in your design or architecture. But these are all kind of, come together. So that's why the previous, the phrase, patterns within patterns and patterns on top of patterns, they all kind of, make sense. So if there are different ways of looking at patterns. They help to, design things quickly or faster and associated with a problem sometimes, like, have the singletons or factories and things like that. And then offer solution, yes, true, can consequences. If you use the right pattern wrongly, or if you don't know how to use the pattern, then it can kind of, get into issues. And very opinionated. Like I said earlier, a few years ago when I was giving a talk and I was going through all the cloud and serverless patterns, and someone later commented that, oh, you didn't talk anything about the classic pattern. I asked, what do you mean by classic pattern? Oh, all the factories and the singletons and things like that. So, people kind of think different ways based on the, the background and experience. And often people say, oh, serverless is a pattern. I don't know. So that's, okay, so if you look at the traditional design patterns, we can kind of classify them into 3 different groups. So we have creational patterns, and we have structural patterns, and then the behavioral patterns. So if you look at the Gang of 4 Patterns book, if we kind of group them, we can see these sort of the different, the patterns and that are in place. So, for example, when we say behavioral patterns, the observer is one thing, and structural pattern, adapter, and facades, and so many other things. So they all come together. But if you take a different view, say a high-level view, then we can kind of classify into 3 different ways. So we have coding patterns, we have design or architectural patterns, and the modern days we have patterns associated with a cloud architecture, because cloud has an influence. Cloud has something to say. How we kind of scale up servers or do something else, load balancing. So those areas may have patterns. So same as serverless, as it falls into cloud, so it has its own kind of way of defining certain the solutions for problems. So design, there's always overlap, right? So because when we have architectural patterns like a CQRS, we need to do the implementation for that in order to make it work, right? So there is always the sort of the overlap. And when it comes to cloud, again, these sort of the strangler patterns, very common, especially we use as we migrated towards cloud. It's one of the common patterns many teams make use of when they migrate to microservices or cloud from the legacy platform. Orchestration, choreography, this is like always the debate. What do we use, orchestration or the choreography? It's like the typical kind of fight between REST or the GraphQL and this and that. So all these things are the circuit breaker, classic pattern, thousands of different types of implementation. So you choose which, what is the best one for you to kind of put together. So this is kind of the way I kind of see those as the classification. But serverless now cross-cuts all these areas across. So that's why I said serverless kind of is being part of cloud evolution, but then takes things from all over the place. Certain patterns, say for example, singleton, may not be that popular these days with when you write function as a service, for example. But you do have these sort of single-purpose functions you're writing, okay? So kind of in a different way that comes into the picture. Okay, so the same thing I mentioned. So serverless patterns. So we will go through a few patterns. I think if you have, should be very familiar to you. I'm not kind of, coming with any groundbreaking patterns or anything. So we will touch upon 1 or 2 things with examples. Synchronous will start with a simple synchronous one. Asynchronous will touch upon. Functionless. Functionless is gaining momentum. I will talk when we get there. And orchestration and choreography, you can't talk without those things because they form core of the event-driven asynchronous compute model we have these days. And then circuit breaker, I will also touch upon the sustainability. I don't go into the details, but I'll just give you a flavor of where we are moving towards in terms of sustainability. Okay, so synchronous invocation, very simple. Have a consumer, a provider. So consumer is invoking a service, requesting a service. It's fine. You've done thousands of times. Provider is fulfilling the request. The difference is that consumer is waiting for provider to complete the task and get back a response. Simple. There are so many things in place. And where do we use API calls commonly? Usually shorter duration because you want to get this done, especially when you have browser or the web apps. You have a customer or someone waiting for the response, so you can kind of hang around and do everything else. And mostly you get into this sort of the coupled situation. So service to service, or you have the knowledge of the service, there is a contract, and et cetera, et cetera. So same thing, item shipping, putting something into the basket. Like I mentioned earlier on, the typical, the e-commerce flow. Now, how do we use it? So we have a shopping app, an API, a function behind it, push the logic, and there is a platform or a third party or a different service behind the scenes, fulfilling. So obviously, when you drop something into the basket, bunch of things go behind the scenes, like validation. If you are a signed-in or a registered customer, you will check the age, make sure that you can buy this product, this country, all sorts of things happen. So performance, again, is a priority. Logic valuation. There's no kind of, in these situations, a partial failure. You say either success or failure, right? You can't simply go in between because customer won't understand any of those things. And the validation step is crucial because that's what kind of makes it mostly successful or failure. And the thing is, though it looks simple, what if your platform, the third party, is on fire? Okay? Because that needs to be taken care. So now you have a broken circuit. We'll talk about the circuit breaker pattern later. So this is something we need to take into account. Even though synchronous pattern looks very simple, it can trip everyone, okay? Especially in a high volume situation. These are the things that we need to keep in mind when we implement these sort of things. So this is where the the circuit breaker or the caching and so many other aspects come into the picture. Okay, now let's stretch it further. So you put something into the basket. Now you're ready to make a payment, and then you need to know what are the available payment methods for you, because it could depend on if you are a customer, you already saved few of your cards for payment. And if you are in a particular country, then you need, the system needs to work out, okay, what are the eligible payments for GB? And if you are a registered company, have you stored any payments that you can make a quick payment with? So those things. So typically, in a situation like this, you would have a checkout service. So that kind of dealing with the front-end aspect of the customer going through the checkout flow. Then behind the scenes, there's a different microservices, completely detached. It's doing the payments business. Okay, so it's going to ask the payment service, okay, here is so-and-so in this country, etc. What are the payment options I should present? So this is actually a thing that we have. The checkout service is a team, and I can mention as squad. And the other one, the payment, there's another squad called Bricoy, and they focus mainly on the payments APIs, all serverless. So the difference is like the payment squad is almost like the service squad APIs, whereas the checkout is like a full stack. So you have serverless and the front end, everything. Anyway, so again, performance should be top notch because there is a customer here waiting to make the payment, and this is a service to service call. So extra things come into play. The timeouts between these different APIs needs to be aligned, okay? Because if this is taking longer and if checkout is kind of timing out faster, then we have a problem. The other thing is quota checks. So in this case, if it's within an organization, it's fine. What if this is provided by a third party? They have limits on how many invocations you can make, and per second or per day, etc. So these things come into place, and also the downtime. Okay, what do we do if it's downtime? Is there a way we can do some caching so that we don't always rely on here? So if it's the same customer who was here a few days ago, there is a cache maybe we can serve, for example. So these sort of different aspects come into the picture. So we start with the standard pattern, then always there is a extra bit that we need to put in place. Okay, so asynchronous. So let's move on to async stuff. So this is quite popular, especially with the event-driven architecture, right? So pattern is kind of similar. Only the difference is that the service provider is kind of carrying on, processing the task, but the consumer is not waiting. So the client is not waiting. Client is carrying on with its own task. doing something, because this is sort of situation where you submit something, bigger task or something, or trigger something with, on a service, and you get on with it. And later on, you will see, you will, ask for the status. We will see, the flavor of it, the CQRS pattern. So again, APIs and events come into play. It's not always APIs when it comes to, sync or async. You can always do a function-to-function async invocation, or event trigger is async. All these, the different aspects come in. And in many cases, it can be a fire and forget. Okay, submit it, you forget it. Then you kind of do some kind of callback or a query to know the progress. And in some cases, you get acknowledgement. So for example, the payment service I mentioned previously. So one of the big consumers for that particular service is the backend SAP systems, because they do the order fulfillment. When they do the order fulfillment, that's when they take the payment. That's when they capture or they settle the payment. So every day, few times a day, they will submit thousands of payment IDs, like 5,000 or 6,000. So there's an API, there's an endpoint that will receive it and will just give back an ID, and that will go away. And they then process the the capturing, and the SAP will kind of poll for details. So polling is one mechanism. You might have heard of the webhook. The other one, if there is a push notification going back to the client, so that's the other flavor of it. Okay, so this is a filtered events to consumers. I will explain here. So this is an event streaming use case. So on the event producers, the web browser and web apps and so many things. So I think you probably are familiar, most of you must be familiar. These days, when you go through a website, e-commerce platform website, every action you do is tracked behind the scenes. You click on a product, you put something in the basket, you're making a payment, completing an order, you're abandoning or something. Everything is tracked behind the scenes via event. So this is this event flow. So event flow is getting stored, and then there is a function that will fetch each batch events or thousands of events, and it will identify group into different types of events. And then there are a bunch of consumers, they will be interested to know. For example, if you spent a minute or two on a page, on an e-commerce page, you suddenly get recommendations. Hey, would you like to see this product? How does that happen? Because this data flows to your big data or a data lake or data insights team. They do all the logic and math and everything, and they will send you back. Okay, this customer, show this product. So so many things happen behind the scenes. So let's see. So let's see how it works. So let's assume that the events come into a data store, in this case an S3 bucket. The dotted line part I will show in a different pattern later. And there is a Lambda function that kind of takes all the batch of events, there is thousands of events, and kind of splits all the events into different groups, and it knows where to send. So behind each target, the targets could be another microservice or the third party, a different team within the organization, etc. So the Lambda function that will invoke the Lambda functions asynchronously. This is not a synchronous Lambda invocation. That is an anti-pattern in my opinion. Never do one Lambda to other call synchronously, because your main Lambda is waiting until, while the other one is working on, so you kind of end up paying more. So this is asynchronous invocation. It's just more like a, fire and forget. So high volume events, dynamic onboarding, I'll explain. So in our case, the list of targets change or vary. All of a sudden we say, oh, we need to kind of send data to so and so third party or internally. So what we do is we have a kind of fan out rule. So this is a simple JSON, this is a simplified version of it, and that is kept in a place. And the triage or Lambda, or the fan out function, will basically read the data from here, and it will then know which events are to be sent to which consumers. So that way, only this part, a new service will come into picture, and this will get edited. None of the other things will get changed. So this is an asynchronous invocation pattern in a different way. So this is another one. So typically, as a loyalty customer, if you go to say a Lego store, and you give your VIP number, and you place an order, you kind of, redeem points or vouchers and things like that. That order data comes back to us, to different places. One of the services will be looking for the data is the loyalty platform. Loyalty platform needs to kind of, do the points calculations and updates and things like that. And also you need to send a satisfaction survey to external parties so that you get an email to, say that your experience was good or satisfactory, et cetera, et cetera. So for this, we have an implementation in place. So this is an order processing, the one that takes care of the loyalty order. Then once it's processed, this is not kind of, client facing. This is background. So it can take its own time. That's why it's a decoupled, asynchronous, all happening behind the scenes. So when an order is placed, everything is good. It spits an event onto the bus, and then it triggers a rule. And this is something called API destination. If you're familiar with AWS, this is from there. So basically, what is representing here is a setup of an API endpoint with the security credentials and the rate limiting and the retries and everything. So this is asynchronous in the sense that this doesn't need a response, because say, for example, compared to making a payment, sending an email or something to get the feedback is not that critical. Even if you lose an event or lose warning, something, that's fine. So this setup, this is where it just fires and, forgets it. So other thing I want to stress here is there is no function written here. This is all part of the platform. So this is again coming to us the functionless thing that I will be talking soon. So rate limiting and secret manager, that's part of it. So because the credentials are kept, so it's used only when the invocation happens. The problems, payload size could be an issue. So your event bus can have a limit on what the data size. Your API, the destination or the the HTTP endpoint at the end may have a different requirement. So that kind of needs to be kind of matched. And the other thing is often we have is the debugging or the traceability issues. So that's always the case when we use the platform integration rather than our own code. But that's kind of the trade-off that we know. Things are getting better, but that's another area that this pattern kind of surprises. So as I mentioned, I written a few blog posts about these things. So this is coming down to the CQRS. So when you finally place an order, for example, there's so many validation happens behind the scenes. One of the main points of validation is the payments. Because payments, depending on the provider, the card, or the bank, it needs to go through many hoops and hurdles, to get back to give you a success or not. So if you think of a 3DS flow, it has a different kind of challenges and things. So it can't take long, seconds or even minute or more. So we can't kind of keep this connection until that point, keep the customer waiting there. So what usually happens is that you take the order, and you then kind of decouple that part. So this is the decoupling part. So this is the kind of function that receives and performs the initial validation. It gives back an order number, then it's completely detached. This is a queue that's pushing into a queue. The other reason is, like when you are on a sort of a high volume sale event, the orders come through in thousands per second, right, or minutes, for example. And we can't process everything in the same speed they come in. So we need to push into some queue to have that buffer. Then behind the scenes, you do the working out. So this is like the command. Okay, here is an order. I'm submitting an order. Do something. And then what happens is behind the scenes, there is a cache table being set up, which will keep the the status of the things. So then you provide a query endpoint to get a status of where we are with the order. This is a common pattern that is in place, the CQRS, the polling pattern one. One thing to highlight here is that the statuses. I think some of you may be familiar with. For example, say the payment failed for some reason. backend service knows exactly why it failed. Either the pin wrong or an insufficient fund, but backend would never communicate that to the front end. So you can clearly change the visibility of the error, because for fraudulent activity reasons, like for people make use of that and they can vary the amount or change the pin and do something like that. So that's another beauty of this sort of separation. So the backend service knows it. It will log or do things it needs to do in such scenarios, whereas the status visibility that it provides to the front end is completely different, because front end doesn't need to know many of the reasons that happen behind the scenes. Okay, functionless. So functionless kind of, the term has been around for a few years now. So it kind of started off with when initially people were kind of doing a function or Lambda function for everything. So I'll put the picture and explain it. So this is typically, you will see, if there is an API, there is behind the API there is a function. I once used the Lambda hammer as an analogy, like those days, when this came along. Architect's tool is, a Lambda hammer. For every problem, they hit with a Lambda. Okay, we need a Lambda function here. But thing is, kind of exploded and uncontrollably, that many number of Lambda functions. So then you have a problem, because people, you start to hear this, code is a liability, something you wrote today is legacy tomorrow, all sorts of things. And don't use functions to shift data. This is a bad thing. If you're just grabbing something here and dumping over there, then obviously there is something missing in your provider service. So this is where the functionless movement started. So how can we get rid of functions where we don't need it? So in this particular case, if this function is not doing any specific logic-related things, if it's simply fetching a data from the data store, can we integrate directly with API? So that's one of the kind of the simplest ways to explain the functionless if you're not familiar with that. So basically what we are doing is like using the native integration patterns. So whether it is API or where is Event Bridge, or if you work with Azure is I think Event Grid and all sorts of things. So how can we use the native integration? Because if you use that way, then you don't need to worry about the cold starts. It's a kind of low latency, low cost. You don't need to you don't pay for the compute for the function, etc. But at the same time, the traceability could be an issue, because when most of the cases that the thing that happens with native integration is like a black box. You don't get to see what's going on inside. So that's the other thing that needs to remember. So this is the data ingestion pipeline that I explained earlier. The clickstream event flowing through, and the service that we use is an API gateway and Kinesis data firehose. This is an AWS service that can take millions of events per second. So this is ideal in this particular case. And this part I explained earlier. So this way basically will batch events. We can dictate what's the size and frequency, etc. But typically you have the Lambda function there. But the question is, do we need the Lambda function? What is it doing? Is it doing anything logic, or is it really shifting the data coming from the API payload to firehose? In that case, you don't need it. So get it off it. There's no need for that. So it's a functionless integration pattern. So like I mentioned, less code to maintain, but also at the same time, we need to think of the drawbacks as well. But this is kind of getting more popular. So behind the scenes, the API gateway will have some kind of script like this. So there is still code, but it's not kind of part of a function or anything. It's something part of the integration setup as well. Okay. So another pattern, another functionless one. So order number generation or customer ID generation, candidate ID generation, in many cases, these are all kind of sequence numbers. If you're coming from the traditional relational database world, you know that if you want to generate a sequence number, you know how to do it, right? So Oracle provides a way, and every other database. But when it comes to serverless, if you work with NoSQL databases like DynamoDB, we don't have an option in place, as popular as the ones we have with the relational database world. So a way to look at, to do is, like this is an example with the DynamoDB, and we can use its atomic number generation. So if you set an API and integrate directly with the DynamoDB, there's no function there. You can do the number generation with the couple of parameters and coming in. You can have different tables, not necessarily just one table for everybody. You can have different tables and generate the numbers. So this is kind of the script, part of the script that will be behind the scene as part of the API gateway integration. So again, this is a DynamoDB script to kind of generate the atomic values. Orchestration is an interesting pattern. So what is an orchestration? So in an orchestration, typically people relate to an orchestra where you have kind of musicians and things there. So somebody is conductor is kind of instructing what to do. And so this is typically in a workflow. In a workflow, you have a number of processes, there's a start, there's a parallel thing or a decision point. So many things happen together before that comes to an end. So it can be long running or even short running, depending on the thing. In some cases, you can pause and resume, not just you hit the start button and everything goes through fine. And also you can introduce kind of delays and timers and things like that. So there's always this question of cross-service orchestration. If you have two microservices, is it good to have one orchestrating resources across multiple services or not? So there's no clear answer, but the general consensus is don't do it, because if you are in one service, an orchestration or a workflow in one service, if you're trying to kind of connect with a Lambda function in a different service, that is a really anti-pattern, because if things change, you are changing two things, right? So that's why people say that do the kind of orchestration, if at all possible, in one service. But now there are ways to kind of distribute. I will talk about that towards the end. But so that's kind of the the general thing. Recently, this became so popular because AWS now has express state function, where it lasts for 5 minutes, but you can kind of invoke it multiple or millions of times. So whether you shift the logic from a big Lambda function to state machine or not. So again, there's a trade-off, because state machine can get complicated with all your kind of if and else conditions and so many things. So, but that the options there. Okay, so this is a simple one. So session monitoring. So when I mentioned earlier that someone going to a Lego store and buying something at the checkout till. So we kind of have a session duration of 2 hours within which that should become. I think that's more than enough for something to be completed at the till, right? The reason we have this session-based thing is because if they chose to, say, redeem a voucher or redeem certain loyalty points, we don't know whether they, the order completed until we receive the order data. But what we do is the loyalty service platform, again, microservices, serverless platform in between, you will do is that it will put those things on hold. It will say, okay, I'll keep these things aside, so you can't, kind of use elsewhere in between, but I will wait until your order is finished. But what happens is that in some cases, orders can get abandoned. So that means you can't kind of hold on to those the rewards and stuff forever. So we have a mechanism. We need to have a mechanism. How can we kind of efficiently identify? So what happens is that as part of the loyalty service, when it knows that there's a session is going to be started, it will send out an event, and it will kind of kick off a state machine workflow. The labels kind of they're not kind of they don't represent the actual thing, but that's what happens. So that timeout. That step will wait for 2 hours, and once it's over, basically it will say, okay, there's no order for this session, so I'm going to send out a cleanup event. So the event goes up. It doesn't do anything. The state machine or the workflow, it will just send out an event onto the bus, and whichever service that needs to perform the cleanup can subscribe to that event, and they will act. Again, these things this happens behind the scenes. This is not again customer facing. So we have the kind of the freedom, the luxury to carry out these things asynchronously and decoupled fashion. Okay, so this comes to the cross-service task coordination, the thing I mentioned. So we have a microservice here. It has an orchestration. Say this is one of the main microservices. It needs other services to fulfill its functionality. Say it relies on two other microservices, B and C. Microservice B has an API and also has functions, whereas C is completely self-contained. There's no API or anything. It's a long-running process. So API call, that's fine. But if you are making that call, like I mentioned earlier, this is probably not a good thing. We don't want to hardwire functions across different services or any other similar resources. And this is a long-running process. What do we do in these situations? So this is where the distributed orchestration comes into picture. So this is a simple view of the loyalty service platforms. It has a bunch of microservices. The two things that I want to highlight are the order processing and the vendor mediator. The vendor mediator is basically dealing with a SaaS platform. All the interactions to do with this third-party application happen here. None of the services will be aware of this chap existing here. The reason we isolated is because tomorrow if business decided to change the platform to somebody else, only we need to write another microservice or modify this one. None of the schema or anything else will change. So that's why they kind of separate. So the problem is, as the order processing goes through a bunch of things, it requires this one to do 2 or 3 things with a third party. And on success or failure of this interaction, it will decide whether the order is successfully processed or not. So this is the state machine behind the order processing. A bunch of steps to identify whether it's a VIP, non-VIP, sale, return, mixed, all sorts of things. But along those lines somewhere, it needs to interact with the other one. Okay, update the order to to the platform. So, and then this service has no public API. This is completely 100% event-driven. So that's how kind of architected that way. So this is where the distributed orchestration comes. So we have 2 services, and task one service then invokes the other one, and it will wait for the other one to complete the task, and then it will carry on from there. So if you are if you're familiar with the AWS step functions, they introduced something called task tokens recently. So basically what you can do is you can issue an event or instruction with a token. It can go anywhere, right? It's not kind of targeted to this service. That's a part of the implementation. So whoever is fetching the event with a token can carry out the work. It could be an orchestration or it could be a function or anything. And then once it's done, send the callback with a token. So the token will go back, and then there's a way we can identify, okay, so now you can proceed. So this is kind of the simple representation. So the task sends out the token, the yellow boxes, and once it's done, there's an event. That event with that same token goes back. There is somebody listening for the event, and then will resume. So you can do for different arms of a particular state machine flow, not for the entire, it's not just one for the entire thing. You can have as many arms and as many wait and resume tokens. We can do as we need. So this is another powerful. So this gives us a way of distributing this sort of orchestration across different microservices. But you need to be careful in terms of who can subscribe to these events, because in these sort of situations, we are targeting the events to somebody specifically. It's not the typical, I would say, event-driven publish, subscribe, anybody can do anything, because in this case, that anybody can't do everything, because we are kind of targeting to specifically. So if you have a bunch of microservices, you can carefully kind of distribute and get over the problem. Okay, choreography is the other side. So with choreography, there is it's always related to the sort of event bus and publish subscribers, because like in any dance movement, for example, each one is instructed to carry out their part irrespective of others. So as per the music and the tune goes, they simply perform, right? Nobody is talking to them, nobody is instructing them, they just perform. Same in this case. So something happens in an event, in a service, pushes an event out. Okay, it's job done. And whoever else needs to subscribe, already subscribe, and they will then act based on what needs to be done. So in the previous example, as I showed you, the vendor mediator, as it receives the event, it knows exactly what needs to be done, update the order, et cetera, et cetera. Similarly, different services, they know exactly what they do. So a couple of things. The idempotency is important because not all event bus implementers guarantee once only delivery. It could be, sometimes duplicates go. When I go through the circuit breaker, I will talk about that. And the traceability can be an issue. So one of the ways we do is like an event can carry an envelope with some kind of a unique ID, so that you can take to all the way to the different services, wherever the service that, the event that flows through. So this is a feature we developed a while ago. So someone coming onto the site looking for a product, they say it's not available. So this feature is basically register your email so that we will notify you when the product is back in stock. Okay, simple to talk about, but there are quite a few things involved behind the scenes. As a feature, it looks simple, but there are different microservices come into play when we implement, because there's a registration part. Somebody needs to look after the email addresses like PII, GDPR, et cetera, all combined. Then somebody needs to notify the customer, and there's a service that constantly working on the status of the products and stuff. And on top, you need to generate the data insights and the business analytics. For example, business will be interested to know how many registrations we have for this product, and also they would like to know how many customers bought the product based on the emails, because if you're not familiar with the email notification process, as we send out emails via, say, SES or on our email provider, you can receive back the feedback. If necessary, we can know whether you open the email, whether you click the link inside the email, all these things. So all those information come back to give the business the details they need. So this is roughly a architectural visualization of the solution. Not everything in place, but on one side we have the registration. Its job is just registering. It doesn't do anything. So what it will do is it will get the details from the customer via the browser, set an event onto the bus. Its job done, and somebody else is taking care of storing those events, and there's a stock checking one, so that will basically check the stock data continuously and push events, and the notification will be listening for those events coming as product coming back to stock kind of event types. So then from there it will kind of kick off the event flow. So the email feedback, this is what I mentioned, that all the receive, I think AWS supports like 9 or 10 different types of feedback you can receive, like marking as spam or undelivered and so many things. So they come back and they kind of use for the business insights. So in terms of microservices, so they set up the dotted rectangle. I mean, this is simplified view, but that's kind of the way the things are split. And another example of how these different services come together and to work in a kind of choreographic way. Right. So just a quick one. There's always this debate, and like I already mentioned. So when do you use choreography? When do you use orchestration? So like I mentioned, if at all possible, stick within a service if you're doing orchestration. Whereas choreography is like coordinating between different microservices. I mean, these are not kind of hard and fast rules, but following this sort of principle will help us to avoid tangling of microservices as you kind of grow your ecosystem. So circuit breaker. So there are hundreds of ways of implementing circuit breaker. So this is a different approach. So when you invoke an API, if everything is good, yeah, it's fine. Circuit is closed. When the service is on fire, you can't reach anything. Service is, the circuit is open. Nothing can go. So usually, typically in a circuit breaker situation, what you will do is you have some kind of a service status monitoring, okay? So you look at, okay, this is green, is this good? Okay, fine. Is this completely blocked or is it, half open? And you keep an, the threshold and some logic behind the scenes. So the thing is, like in most cases, when you send requests to a different service or a third party, if they are down, you need to resend all those things, right? So you need to take care of, okay, how do I get hold of or keep hold of those failed requests and I can replay them. So that's probably the hardest part here. So, okay, that's fine. So coming back to the service, the one that the vendor mediator. So this SaaS platform, somebody else, third-party platform. So we can't take it for granted that it's going to be there all the time. Especially this platform, as part of their CLA, it says that it will be down 6 hours per year. Okay, so there you go. So you can't simply assume that it will be there. So you need to do kind of 3 invocations happen per, up to 3 can happen, 1 to 3 can happen for every successful order. So that's why it's important for us. So the way we was using a feature of Event Bridge from Amazon. So they have something called archive and a replay. So that is what we use. So just to call out, the storage first pattern is something you might be hearing these days. So what happens is with the asynchronous decoupled way of doing things, the pattern is like when a service receives a request to fulfill something, the first thing it will do is kind of store the details somewhere before acting on anything. So this kind of helps if it needs to replay or come back to the service for some reason. So that's a pattern that you probably will hear now. So when it comes to third-party applications, in my way, there are three cases. So success, fine, everything is good, fine. Error, hard error, if it's something to do with the data, no matter how many times you try and resubmit, it's going to hit the same error. Okay, so that needs a different treatment. That needs kind of business need to take know the data and liaise with somebody to get over. Whereas the retries, whether it is down or timeout or the typical service unavailable issues, those needs to be harvested and you need to kind of replay. So what happens is like this particular service, at the back of every order it processes, among many events it will send out. These 3 events go out as well: success, error, or the retry. So we will be looking for the retry events coming out of the service. And then we set up something called an event archive. So this rule, an event coming through this pipeline or this flow, we know that they only get the retry events here. So what happens is it's kept in a archive, which is part of the service itself. And what is an archive is basically a collection of events. So you need to set up a filtering and routing rule behind the scenes, so it knows, okay, so these events I'm going to keep. You can create multiple archives. So if there are different types of services or events, you can create different archives so that you're not kind of putting everything together and making a mess. You can target individually. Remember the granularity I talked about earlier. So that's there. So in addition to these things, there is a setup behind the scenes, basically looking at the status of that third-party application. So that's based on a cron job. It runs, I don't know, 1 or 2 minutes, every 2 minutes, hitting their status endpoints to make sure. So every invocation, it updates the details onto the status table. And behind the scenes, there is a Lambda listening for all the status. And there's some logic here. It will look at, okay, what's the threshold? Threshold I need to now look at. So if the system is in down for long and suddenly it receives an event via this update saying that, oh, hey, third party is up now. Oh, okay, then this will kind of come alive and look at a few parameters. Say, okay, I'm now going to trigger the replay of those events kept in that archive between these 2 time frames, because that the function knows when was the last time it was up or down. So based on that, the events will be played back to the bus, and it will go back to the service, and the flow will continue just like normal. and if things have failed again, so we'll come back here. So this probably may look like a kind of expensive circuit breaker implementation, but in our case, because the reasons I mentioned, the decoupled nature of the services, and we just simply couldn't want to kind of, scan the table for, because we don't know how long will be down and how many items will be in the table. If it's like a handful of items, okay, fine, we can do a query or something. We don't want to kind of query thousands of items. So in our case, behind the scene is the NoSQL DynamoDB. So there are kind of the trade-offs we looked at, and we have this kind of implementation in place. Things to watch out for: event exodus, because the third party may not handle the volume of events all of a sudden coming out of your archive and hitting. So that's why you need to kind of have the the throttling mechanisms or the buffering mechanisms in place to make sure that you don't hit the third party a lot. I mean, often people ask, say for example, most websites, many websites these days, I mean Lego.com also, we have this queuing mechanism during peak sale period. So if you want to buy something, you'll be in a queue. And people ask, oh, you're running on serverless, then what's the point in kind of having this queue? Can you not scale? It's not for the the serverless that we have to protect. It's for all the third-party applications that we interact. Because if they can't cope, then we have a problem. So it's difficult to explain, but a question that comes again and again always, because they think that serverless scales up indefinitely. Yes, it can be, but we need to kind of look after the ecosystem around. So that's the thing. Okay, quickly on sustainability, because this is a hot topic these days. And especially as cloud providers started to provide mechanisms of measuring carbon footprint and a bunch of things, so everyone is now conscious. But if you look at sustainability itself, it's not specific to the environment. Even though the planet and environment gets the focus, it can be anything, right? Because it can be related to a product. We are building a sustainable product. Things like, for example, can you extend the product beyond your 2 sprints? Or are you going to kind of start all over again? So that needs to be part of it, because we kind of gone away from the typical maintenance mode, and we are kind of more into sustaining the products, right? We start with the MVP and kind of iterate and go forward. So we need to think of how can I sustain my product itself, not just do it for once and dump it for maintenance. So those days are gone. And also what are the processes that help in my sustainability journey? And of course, the cloud comes in. What do they provide? What we need to take care of? So this is what I was saying. So that's gone. These days, more of a sustaining things. How do we operate? Single microservices. They go out, and so for that, a couple of things we need to take into consideration during the design or architectural thinking. So can it be modular? Can I extend it? How can I observe? So these elements are important to build sustainable products. So processes, similar. Liz was talking about the lean principle in another talk recently. So those things come into place. How do I reduce waste? So if you are kind of keeping if you have a very bad value stream, and if you are keeping resources running until you're queuing or deploying, that means you are kind of unnecessarily burning resources. So these are the things that you need to take into account, and also, the most importantly, automating everything so that there aren't any manual delays. Everything is automated. Things are tidied up once the job done, etc. So when it comes to cloud, AWS kind of puts out this sort of a responsibility in 2 ways. It's a shared responsibility. They do their part, or it applies to any cloud provider, not just AWS, right? So they provide their part, and we need to do our part as well. So in terms of what they are doing, cloud providers do is the renewable energy, and they do the resource sharing and all sorts of things. Whereas when it comes to our side, so we use managed services. Serverless gives a step ahead, but plus we need to kind of get rid of the unwanted resources, data storage, get rid of them, don't keep them, because they all kind of, in the end of the day, consuming power and other resources. So there are a bunch of, the patterns. They kind of help with how can we, improve the situation when it comes to sustainability. Okay, so that coming towards the the benefits of patterns. So like I mentioned earlier, so this is where we started. So simple pattern, an API gateway and Lambda function, people won't even consider as a pattern these days because they're everywhere, right? So that's where it started. So, and from there, things moved on. And this one, I show you the Kinesis Firehose thingy. This pattern is repeated, I think, at least 3 other places. The email feedback, the mechanism I mentioned, that has Firehose behind the scenes, because when you send out hundreds of thousands of emails, you can expect to come back, the feedback coming back in thousands, right? So that's sort of ingestion pipeline that we have. And the development acceleration. So this is one of the earliest data processing pipelines we put in place. So SAP feeds will drop into the bucket, kick off a Lambda, they have a queue, and Lambda hit the platform on the other end. It's all fine. And so the SQS allowed us to kind of vary the speed of the flow, because in certain product feeds, like product price, that needs to go super fast to the other end. Whereas if a feed is related to somebody's product feedback, okay, so that can slow down and let everything else go. So with SQS, probably if you work with SQS, you know that you can kind of vary the delays and visibility timeout and things like that. So those aspects allow us. So the reason I put out this one is, but this is where we started. Now we have over 18 pipelines. In a pure software engineering mentality, this is nothing but copy-paste of the same pattern over and over again. So this is another example of how these things kind of give you that momentum, not for the development team, also for the business to gain that velocity to move forward. So patterns, if you're on AWS, Jeremy Daly is a serverless hero. He's written a bunch of things. And there's a CDK, is an infrastructure as code kind of area. It has a bunch of patterns as well. And there is a serverless land. So if you're in AWS area, they have tons of things there. You will also get the code samples and all sorts of things. So make use of all those things possible. Leave you with this one. I think it's one of Vogels from Amazon a few years ago. He said, he said, all the code you write in future is business logic. So if you think of the functionless and the integration patterns and things that we are kind of moving towards and getting popular, maybe one day we will just write the business logic and leave everything else to the, the platform and everything else to do the magic. That's all today. Thank you so much. Thank you so much for listening. I'll be, if anyone interested, I'll be around today until the evening.